So we have talked about resting membrane potential, which is basically the membrane potential in the resting state. So in order to transmit certain stimulus or impulse or certain information, we need to carry it out through to various types of dynamic potentials. So there is a particular threshold for excitation. From the resting state, we need to go till a certain threshold potential, and from that it will fire till it reaches a peak. Say for example, this is the baseline and this is the level. Say suppose we give a stimulus, an electrical stimulus, and potential shows a curve like. So in this case, this is a sub-threshold stimulus. So along a nerve fiber, this sub-threshold stimulus is incapable of transferring the information. So suppose this is a particular segment of the nerve, or say suppose a particular area of the membrane of a Schwann cell. This information will not propagate because stimulus is not sufficient to carry on the information throughout the nerve fiber. So this gives rise to a local potential. In some particular region, say for example this region of the membrane, there is a local potential. It does not transmit further. It has to cross the threshold potential to a higher peak, and ultimately get transmitted along the nerve fiber. So this is called action potential. You might be familiar with all or none law. This law specifically applies to nerve impulses, and it states that first, stimulus intensity below the threshold level, resulting in potential peaks below the threshold potential level, will not give rise to any action potential. Sub-threshold stimulus will not give rise to any AP. So the neuron will fire only once stimulus has reached the threshold potential or above. But once it has crossed the threshold potential, any stimulus of higher intensity will not produce any change in amplitude. So stimulus. Also it is applicable to motor fibers. For motor fibers, the all or none law suggests that the stimulus must one motor unit. Now we'll study a bit about these local potentials. So what are basically these local or graded or generator potentials? So graded or local potentials arise because of sub-threshold stimulus. These cannot excite the entire cell or the neuron. These are localized and confined to a specific region in the plasma membrane. However, graded or local potentials can be summated. This is nerve fiber 1 and nerve fiber 2. So the potential or the action potential or the information will pass from 1 to 2 only if a certain threshold is reached. So suppose this is the threshold potential for this neuron, a certain graded potential caused by a threshold stimulus. Say suppose there is repeated stimulation by this particular nerve fiber such that all the stimuli get continually added, resulting in a scenario where it actually reaches the threshold potential. After this, it is able to fire. So this is called temporal summation. If the summation was something like, these are numerous presynaptic fiber ones. Here the summation would not be to repeated stimulation from the same nerve fiber. In this scenario, threshold potential is reached because of summation of individual stimuli of numerous nerve fibers. So this type of summation is called spatial summation. This postsynaptic potential can be either excitatory or inhibitory postsynaptic potential. So graded potential can be of these two types. When there is secretion of excitatory neurotransmitters like glutamate, acetylcholine, aspartate into the synapse, these result in opening of the sodium channels. on the postsynaptic membrane such that there is an influx of sodium ions. Now, as there is an influx of sodium ions, these will cause the potential of the membrane to go from a resting -70 to a slightly more positive side. So suppose -55. So this graded potential will bring it closer to threshold potential by this depolarization. Whereas inhibitory postsynaptic potential occurs when, say, suppose an inhibitory neurotransmitter, for example, GABA, gamma aminobutyric acid, or glycine, is released into the synapse. So what happens? These cause opening of ligand-gated chlorine channels on the postsynaptic membrane such that more chlorine ions enter the cell, and the interior of the cell actually becomes even more negative. So from 70 it probably becomes -85 or -90. So if the threshold is somewhere like -55, it will actually bring it farther from the threshold. So the graded potentials can be excitatory or inhibitory. There are other ways to classify graded potentials. Like, for example, you can even classify excitatory postsynaptic potentials into fast acting or slow acting. Fast acting, fast EPSP is when acetylcholine acts on nicotinic receptors around 30 milliseconds, and slow EPSP is when acetylcholine works on muscarinic receptors around 30 seconds. Thank you.